What's going on, Usagi? How you doing? How goes dog petting sim? Do you have any more time today to work on sprites, or did work get in your way today? Work. That sucks. Yeah, feel you there. I'm actually starting a new job on Monday, concluding my period of fun employment. I'm looking forward to it. It'll be a cool job, but not having a job is cool too. There's no denying that. What the hell am I working on? Oh, nice. Okay. Do you use those for, like, just for fun, or do you actually use them as part of your spriting process? Meat space art. Okay. Yeah, right on. I don't know if you, like, started in meat space and then, like, you know, sketched or something and then went to digital, but you just do drawing and stuff too? Just has, like, its own discipline? Nice. Okay. Dollhouse miniatures. Do you, like, carve from balsa or 3D print, or how does that even work? I don't know anyone who does that, as far as I'm aware. Fabric arts. Okay. Or is that a different category? You mean, is that not related to dollhouse miniatures? Fair enough. That's cool. I used to do a lot more physical kind of maker stuff when I was a kid, but last couple of years I just, like, overwhelmingly my creative energy goes into software now these days. Miniature book and a mop. Interesting. That's cool. A miniature book, like, with illustrations and stuff. Empty book, okay. Yeah, I'd like to see what you're talking about. Like, I kind of know, but not really. Okay, please do. Yeah, absolutely. I appreciate the question, but please share all the dicks you want. No problem here. I'm looking at the Discord. What's the gold tooth? What did you do that in? Is that marker or something? I can't even really tell. Looks cool. Oh wait, I guess it's watercolor? I'm zooming in a bit. Or marker? Yeah, marker, I guess? Copic markers, okay. When you said Copic markers, for some reason I was thinking of like those dry erase markers, but I guess that's not what you mean. What is that? Copic marker. Oh, Copic is a brand, okay. I see. Okay, yeah, I've seen these before. That's pretty cool. It seems like marker would be like a super unforgiving medium, isn't it? Because, I mean, you make one mistake and, like, you can't really back out of it, can you? Boring's just practice? Yeah, makes sense. Just gotta get good, I guess. Oh, whoops. Stupid. I used to draw a lot when I was a kid and stuff. I was okay at it. I guess I did it in college a little bit even. But I never tried marker or anything. You know, with pencil, it's just a lot more forgiving. I think the most unforgiving medium I ever worked in was probably like pastel or something, but even that, it's not that bad. If you fuck up, you can just kind of paint over it, you know? But yeah, respect for being able to work in marker. I think working in software, if you want to consider software an artistic medium, has really spoiled me because I can't think of anything more malleable than software. At least to a degree. What'd you do the Pikachu in? Is that... That's not hand stitched, is it? 'Cause that looks very, like, precise. Is that like cross stitch or something? I don't really know anything about fabric arts, like, at all. Oh man, cool Deadpool and stuff too. Cross stitch, okay, yeah, alright. I really like that Deadpool. That looks like super good. Have you just been doing art like forever? I know you're talking about, you know, you've been doing pixel art stuff forever, but I guess you've been doing just all this stuff for your whole life, or what? Took seriously in high school? Yeah, okay. What else we got here? Yeah, I want to see Barbie's bondage dungeon. Please do send those. When I was in college briefly, I thought I was going to go into digital arts and sciences. I made some kind of stupid stop frame animations with some friends. I should see if I have those anywhere to show you. They're probably lost now, but they were kind of funny. Okay, so what I'm trying to do here tonight is make the AI just incrementally less stupid. I still do want to probably try the neural net thing, but the more I was thinking about that, more I realize that I think I'm likely to be more successful attempting that if I understand the problem better, the kind of old-fashioned manual way. So with that being the case, my only goal for tonight is to get the AI to a point where it can fire on you, and that shouldn't be that involved. And then I've been thinking more about the math of, so there are like 3 levels of sophistication here. We're going to hit level 1 of sophistication tonight, which is just like, it's technically possible to lose. But by the end of the night, the AI is still going to be very stupid. The second level of sophistication is I'm kind of working out some math, which should, I think, make the AI relatively capable. Yeah, that's what I'm thinking. Like this will kind of incrementally move me in that neural net direction. And should I find the neural net thing too difficult or impossible or something, at least we'll have a playable game, a playable one-player game. And I'm confident I can make the math solution work. The other nice thing about doing the math thing first is I'll at least have a benchmark of how much code it would take to implement any solution. And that'll just be a useful frame of reference when I do consider the neural thing, because maybe it'll work, maybe it won't, but at least I'll have kind of a code budget in my head. So the thing I just did now was I wrote some little helper method, which we can probably get more mileage out of, but it just sorts the units that are on the stage into friend and foe relative to the current player. And tonight all we want to do is select a random computer unit, and if there's a player unit within that random unit's attack radius, shoot at it. Even this can get slightly tricky because the one computationally expensive operation that there is in this game, at least so far, are calculating radii. And to really do this thoroughly, we would kind of need to update the radii of all units on the board with every turn, or at least not update them all on every turn, but at least have them. So I don't think I want to do this tonight, but another idea in my head is when the stage loads, it's probably worth computing every unit's radii and then storing those hot in memory, and I think I have enough memory to do that. The RAM is like the only limitation I haven't bumped up against so far in Pick 08. And then, you know, so we keep that in memory, and then we only update radii when a unit moves, and that will probably be fine. We'll have to be mindful not to run out of memory when we start having lots of units, but we might be able to get away with that. But I don't want to commit to that yet, though, because that's sophisticated and dangerous, and I don't want to write code that I'm not confident in yet. So let me double check this, but I think we are already doing half of what we need to do. Which is just... yeah, okay. The detection, I think, will be different in my case than that guy, because that guy, he was doing collisions, you know, against like a bitmap, right, against the video memory. What I'm doing here is just logically operating on grid data in Lua space. So I don't think anything that he did will be directly applicable to this. But I'll think about it though. One thing that guy did, you know, that may or may not be applicable, but I'm always impressed when I see people poking around in memory directly. That's something I've basically never done, at least on any real project. And you know, I think that kind of direct interaction with the hardware is probably kind of characteristic of pick a weight. I've never done it, so that's kind of a new way for me to learn to think. You know, because outside of pick a weight, there's really there's seldom a good reason to do that, and there are many good reasons to not do that. But again, the charm of pick a weight is that you kind of have to get your hands real dirty sometimes. But okay, so let's just start with the really naive solution here, I guess, right? So we have an enemy unit. We've just chosen at random. Obviously, that's not what we're going to do ultimately, but we've chosen an enemy unit at random. We've updated his radius. Actually, here. So we want to see. We want to what? We want to iterate over each friendly unit and see if that unit is in a cell within either the movement or attack radius of this guy, and if so, blast them, and if not, make a random movement. Yeah, you know, that article did get me thinking about, you know, effects and stuff. Like, I still haven't put a huge amount of thought into the visuals of this game, beyond the spriting stuff that we've talked about. But, like, the effects and stuff, like, the effects are all still placeholders and garbage, right? Like, I can do better than that laser, probably, and I can definitely do better than this explosion, which is, like uncomfortable to look at because of the screen shake and stuff. But yeah, that guy's article got me thinking about, like, what kind of cool visual effects can I do for lasers and explosions, and, like, I was even thinking I could probably just use my palette swapping mechanism to make, like, some maps that are at night, and if I did night maps, that would be an opportunity to break out, like, the cool lighting effects for lasers and explosions in particular. Again, the only reason I'm not committing to that plan now and saying, yeah, I'm totally going to do that is because, like, I still need to see where I am code budget-wise, but if I could do that, I think that would be super cool. I've started thinking more about the visuals of the title screen, and I keep coming back to this image. I should just, like, add this damn thing to the repo. I talk about it so much. I keep coming back to this image as just being, like, the kind of inspiration for the whole project. It annoys me because I say that, and then aside from the fact that there are triangles, my game doesn't look a damn thing like this, and maybe that's something to think about. But I'm thinking, like, maybe I could just do this kind of cool animated HUD thing for the title screen, because, you know, you can draw a couple of circles, you can move some triangles around with relatively little code, right? And I think it would look cool and maybe help to communicate the aesthetic I'm going for. I was even, like, getting crazy and thinking, you know, I could just reskin this whole thing to be wireframes and shit and look more like this, but I don't know if the pick-away palette would lend itself to that. And I don't know if the player would... I don't know if that would benefit the player or not. I don't know. Yeah, there is a secret palette. I don't really know too much about it, other than that it exists. But that is an option, is to go to the secret palette. But yeah, I don't know. I don't know. I need to think about that. I just had that kind of idea today, but I could pretty easily do something like that, and that would at least be satisfactory. The only other thing I might do tonight too, if I, like, well, I don't know. I probably shouldn't do this tonight, but I might just write some stupid helper function to, like, create text with, like, an outline, like a stroke around the text, because I might need that. But that's probably stupid. I probably shouldn't do that because, again, I have a like a pretty tight code budget. Call it in the draw stage. I have no idea. I think you like poke something in memory, right? You poke some flag in memory, and then you like just the indices, the color indexes map to different colors. I think, but I don't actually know. Yeah, it does look like a little bit of a process, and I'm not even really sure if those colors are better suited to the idea than the default palette anyway. I don't know. They might be. I've never really given too much thought to the... Okay, yeah, so you do pokes up in memory or whatever. I don't know. I've never really read too much about the secret palette beyond knowing that exists and taking a glance at the colors. Yeah. Yeah, color theory-wise, there's really not a lot of... I haven't done a lot of thinking about it, to be honest. You know, I'm just kind of like picking colors that are relatively like easy to parse at a glance, I guess. But I certainly am not doing any color math or anything sophisticated here. Just kind of fucking around, really. I was also thinking about maybe trying to like add just a touch of like an isometric perspective to this, but again, I don't want to get complicated. I don't think. I just don't know. I just don't know. But anyway, yeah, tonight I should just push that out of my head, I guess, and get this thing done. So what? We want to loop over foes. I need foes now. Yeah. I've really been enjoying Aseprite, by the way. That's really nice. I was super impressed when I saw that you can just like load the pick away palette by default. That's super cool, I think. Right now, my spratting process is I do everything in Aseprite and then I just import that PNG into pick away. That's been working pretty well. You know, I'm even fine with the native editor in pick away because I'm not sophisticated at the art, right? But I do like Aseprite better. There's also posted on BBS some like plugin for a program called Tiled that I guess people use for making like 2D tile maps, and the plugin made that thing compatible with Pick 08. That's pretty cool too. You made a secret palette. You hacked the thing a little. So correct me if I'm wrong. If you use the secret palette, you still only get 16 colors, right? You just get a different 16 colors. Is that correct, or does the secret palette actually extend the colors? Oh, really? You can have 32 on screen. Okay. I didn't know that. I thought you were just getting, like, a different 16. If they do not mingle either horizontally or vertically. What do you mean mingle horizontally or vertically? Are you just saying that the indexes will collide? Okay, yeah. Is it like you draw something and then you poke that memory address and then you draw something and you poke it again, that kind of thing? Is that how you get all 16? You can just keep poking that address as you're drawing? Is that what's going on? Okay, that would make sense. Oh, you did. Okay, the Barbie stuff is pretty funny. Is that what you did in college? Like, actually for class? Also like the rupees. That's pretty cool. Nice, nice. What did you do the rupee things out of? Looks like acrylic with like a 3D printed... Okay. Is that like 3D printed skeleton with like acrylic? Yeah, okay, okay. Made the tassels, okay. Those are cool. That's pretty good. I like that stuff. Nicely done. I guess, is that watercolor too? What do you got in there? Or like... Or is that crayon? I can't... Or marker again. Mixture, okay. The hummingbirds one is really cute. I like all the little fantasy dudes riding them around and stuff. That's good stuff. Colored pencils, okay. What do y'all call them? Pencil crayon. Weird, okay. Yeah, show me the old sprite sheets. So did you just sprite like standalone stuff, or did you work on games, or what did you do? Standalone stuff? Okay, that's cool. Okay. I've never heard of Bob and George, but I was never really, like, into digital art before. I guess I'm kind of getting involved now, and it's pretty cool. I'm having fun. Okay. Oh, cool. What did you use back in the day? Like, I don't know how old Sprite is. You've been using Sprite forever, or just like paint, or what? OG paint? Okay, yeah. Makes sense. Okay. I used Photoshop like twice in my life and was kind of overwhelmed by all of the stuff you can do with it. Same goes with GIMP too. I appreciate that they're both hugely capable programs, but I'll be damned if I can make them do anything that I want them to do. If the foe is within the CPU's movement or attack radius, target it. Oh god. Oh fuck, this is so more... Oh my god, fuck. This is so much more complicated than this. Oh my god, fuck. This isn't correct at all. Yeah. No, I totally don't have this. So what... Okay, so what I realized... What? Oh, fuck. Oh, God. So, okay, so what this is going to do is... Yeah, fuck. The way I was writing this, if a player unit was within the enemy's movement or attack radius, the enemy would just fire from where it was at the unit. That's not correct though, because the unit, the enemy would likely have to travel to some nearer location and then fire. And that like implies a bunch of like A-star pathfinding to know where the thing has to go to shoot the laser. So yeah, this is entirely too naive. This is just wrong, what I thought I was going to sit down and do. Yeah, so I'm trying to think like what the chunks even are, right? I actually previously got a bunch of it. Can you not use sprite flags? No. So here, let me visualize the issue. What, this all comes out? Here's the problem. So let's say I move here. Now, the code I was writing would have checked to see, like, let's say that this enemy unit was the one that was selected at random, right? And this guy wants to make a move. The code I was writing would have just fired a laser at this guy from here. But that's not correct, because his attack range is 2, right? So what has to happen for this to be correct is that the thing needs to move nearer to me, like here or here, and then fire the laser. But now we have to implement some logic of working backwards, right? Where it must know, okay, we can shoot this unit, but we can only do it from this square. And that is problematic because there are kind of two strategies that we could take to work that out. One would be when we're computing the radii to store the for each cell visited, store the ID of the like parent cell, the cell you came from, when you reached a certain cell. But even that is actually difficult for two reasons. One is then we like exponentially increase the number, the amount of RAM occupied by these radius tables. So that sucks. You know, given that down the road we will likely want or perhaps need to store all of these in memory, right? So that gets tricky fast. The second solution is abandon that and use A-star pathfinding and just work out. And I think it would be correct to say, can unit C X and unit fire X? What do you mean by that? What do you mean by that? But then, like, the other thing we could do is use A-star to pathfind from where we are to where we need to be. But even that will be non-trivial. For one, because we have to use A-star, and I actually already wrote an A-star implementation for this project months ago, and then I ripped it out because I wasn't sure we were going to need it. But now it's possible we need it. And the reason I ripped it out is because it was fairly large. Probably 500 or so tokens. X being the value minimum needed to perform either move or fire. So the issue isn't one of like movement points or whatever. The issue is of spatial placement, right? Because again, let's do this from our side, right? The code that I was going to write would be as if I, from here, tried to shoot this guy now, right? And, you know, you can see that this enemy is within our attack radius if we move first, right? If I move to here and then shoot, I can shoot. But I accidentally moved. But if I hadn't moved and then tried to shoot from where I started, he would have been out of range, right? So the enemy AI has to be able to work out the spatial positioning of knowing, like, okay, this unit is within attack range, but if and only if I first move to the square that allows me to take the shot, right? And that's somewhat complicated to tease out. The other, maybe the shortcut solution, this is kind of an option 3. It's disgusting. I would hate myself if I wrote this. But option 3, right, would be... God. It would be first determine if the unit is in the attack radius, and that's trivial to do. We've done that. And then find the cell within the movement radius which has the shortest Manhattan distance to the enemy, which is fucking disgusting. God damn. But, like, that would work. It's just fucking disgusting. So, like, what that would mean, Manhattan distance or checkerboard distance. So, this will be a lot clearer if I just show you the The Wikipedia. So the Manhattan distance or the taxicab distance, it's a distance finding algorithm used when navigating cell-based geometries. And the joke, the meaning of the name or whatever, is that imagine you're a taxicab in Manhattan, which is laid out like a grid. So that's what this is illustrating, right? So here's the straight line distance in green, but in blue is the Manhattan distance, right? So it stands to reason, I think, that if we can determine that a unit is within our attack radius from somewhere, then among those somewheres is the cell within our movement radius that has the nearest Manhattan distance to the unit. That's just fucking disgusting, though, because well, we do know how big the maps are because I have to configure that when I'm setting up the levels. The issue is, how do we compute this in a computationally efficient way? And not only computationally efficient, but in little code, right? Which is what's appealing about Manhattan distance, is because, you know, it's like, what's the formula? It's like square root of 3 things or some shit. It's like trivial. I have to look it up. I forget what it is, but it's some trivial thing, right? So, again, the reason this is like disgusting and embarrassing is because, like, it's just like gross. I don't know. Like, it's just gross and wrong and feels bad to solve it this way, because it would be a bunch of iterating over cells, and it wouldn't even be a huge number of cells. Like, worst case, let's just count 1, 2, 3, 4, 5, 6, 7, 21, 25, 29. So let's say we would be doing, on an average case, or like a reasonable worst case, we'd have to loop over 50 cells within our movement radius, compute the Manhattan distance 50 times, track which distance, track the coordinates of the cell with the smallest distance, move there, and then fire. If we didn't trust our math, we could move and then double, and then recompute a radius again, and then double check that we are in fact in range. That's a solution to it. That's so fucking disgusting, though. I kind of hate it. Another option, again, would be to embed when we're computing the... Yeah. Let me look at the radius computing code. So there's only one bit of code in this whole project that I thought was actually hard to work out, and it was the code that computes... Where the fuck is... Oh, it's not this file. It was the code that computes the radii. This turned into like a pile of recursion that was very computationally slow at first. It only needs a check, or could you set it up to only check the minimum amount of stuff around unit, or use a simpler rule set, like if you had the enemy units move in chess-like moves. So, yeah, so, you know, we wouldn't need to do a lot of checking. We would only need to check the space within a unit's movement radius. So again, realistic worst case, we would need to check 50 cells or something like that. That's not horrible, it's just disgusting. But this information is so handy to have that I think I would like to solve this in a more elegant way. Because again, like that thing I had just described is like the duct tape and bubblegum way. That's like just so bad. Logarithms? No, no. So what we need to do, right, is associate each cell in our attack radius with a firing position in our movement radius. I'm trying to think if I can do this more cheaply. If we worked backwards from the enemy unit, I guess we could, like, no, see, so the reason this is difficult, right, is like I'm using the word. Yeah, so you only have so many movement points. That's part of the problem. But the other problem is that each different tile type has a different traversal cost. And to see what I mean, just look at the screen here. You can see that this is not a radius, right? This is not a circle. I'm using the word radius because that's what people use in these games, but it's not a radius though. It's an area that you can travel, and that area is informed by, yeah, that's informed by the terrain and the presence of enemy units and friendly units and stuff. So, like, you know, concretely, you can travel more quickly down the road than you can in the woods, right? So it's not just like the trigonometry of, you know, we can't use trigonometry here because I'm using the word radius, but we're not actually talking about circles or triangles. We're talking about arbitrary shapes. So really, like, so fundamentally, the problem we need to solve, right, is we need to know for each cell that can be attacked which, you know, from which cells may you attack that cell. That gets complicated. For a lot of reasons, especially on Pico 8. Unless I'm thinking about this wrong. It's certainly possible. Yeah, so it's not even a math equation, it's a pile of recursion. Just to talk through like how this works at kind of a basic level is, you know, we have two radii. Well, we actually have three. I can forget what that third one is. The danger. I think I know what that is. Yeah, okay. For the sake of the argument, let's say we have two radii. We have a movement radius and an attack radius. And the movement radius is what it sounds like. It's just how far can your unit physically travel. And then your attack radius is a superset of your movement radius. It's composed of all the cells within the movement radius, but it also contains all of the cells you know, for each cell on the circumference or the perimeter, let's say perimeter of your movement radius, you extend that radius by the number of points you have in weapon range, right? And you can see it more clearly than I can explain it, but like, look at where the blue ends and look at where the red ends, right? So, you know, this is our movement radius, and then the attack radius is a superset of that. It's just that plus 2 from every cell on the peripheral. But again, what we need to do is work backwards from, let's say we're attacking this guy. And see, this guy's a good example, right? We're attacking this guy. So I know, just because I wrote the game, that we could attack from any of these squares. But how do we make the computer know that without doing a bunch of iterating over loops and shit? And I mean, like, iterating over some loops isn't like iterating over some cells isn't the end of the world. It's just, again, it's just disgusting and horrible. No, don't worry about asking questions. The units don't store the tile type at all. When a unit is moved, it is like, so a unit has a radius, and when the radius is being computed, it queries the map a bunch to determine which tiles would be traversed, right? That's what this is doing here. All of this code, or here. But that information is not stored anywhere. That being said, I don't think that information is what we need. What we really need to do is, like, the computation of the radius itself, notwithstanding this problem, is fine and works well. What we... Yeah, because, like, I could solve this the disgusting way, right? Like, here's the disgusting solution visualized. Is like, okay, like here, let's work backwards. I don't. Let's end this turn. Let's work backwards, right? Here's a visualization of the disgusting. Actually, let's go over here. Oh, God damn it! That guy moved. God damn it! Okay, so here's the visualization of the disgusting solution. We can tell now that this unit is in our attack radius, right? That is known. Yeah, no, asshole running away. It is known that we can attack this guy. What we do not know is from where may we attack that guy, or stated otherwise, to where must we first move in order to attack this guy? Because I can't just shoot from here, right? He's within our attack radius, but he's within our attack radius if and only if we first move closer before we take the shot. Because remember, in any given turn, you can move and attack or balance. Now, like, one way to, solve this problem would be to change the game rules such that you can move or attack, but I think that harms the gameplay, so I don't want to do that. So given that you can move and attack within one turn, we then have to be able to answer the question, if we know we want to attack this guy, to where must we first move before we may attack him, right? And again, as humans, we can just kind of look at this and answer the question, but the computer can't do that. So like, I don't even know if Manhattan distancing I said was right. I think it is. Yeah, this is right. So the disgusting solution is then algorithmically we say, okay, we start from here, and then we iterate over every one of these blue cells, and we calculate the Manhattan distance from each blue cell to here, and we just acknowledge that logically, if we know that we are within the radius, or that we can be within the attack radius after movement, we know that the cell with the shortest distance from here to there would provide a valid movement position prior to attacking. We know that, right? That's logical. Now, that sucks for a few reasons. One, it's inelegant as all hell. It's disgusting. Because we'd be looping over 50 or whatever cells for every movement, and we'd be. I keep saying it's disgusting. The reason it's disgusting is because we are essentially doing the same work twice. Because in calculating, when the radius calculates, whether or not we're able to attack a guy, we have already solved the problem of from where would that guy be attacked, right? So this is disgusting in that we would compute the information that we need, throw it away, and then recompute it. That's disgusting. Especially in pick a weight. Like you literally can't do that. So I hate that solution. That would solve it. It would just be terrible. The right way to do this itself poses challenges. The right way to do this would be when, and again, this isn't, I don't know if this will work, again, because of pick a weight, but the more appropriate way to do this is when we are computing the radius with each cell in our attack radius that we visit, record from which cell in our movement radius allowed us to reach this target cell, right? Because then, the absolute most naive solution is, okay, we know we need to attack a guy here. Let's query that cell to see what its parents are, or whatever, right? From which cells may that be reached? And if we just picked one at random, we would then have at least a valid, if not optimal, we'd have a valid firing position. And the elegance there is that that's pre-computed. We aren't computing the same information twice using two different algorithms. Like, God, that's so disgusting. But the penalty, the downside of that, is that for each of these cells, we're storing an arbitrary number of parent cells. And that's not great. Because, again, we're potentially going to be storing a lot of these things in memory, right? So we need to be really careful about just storing tons of data. Yeah, okay. Yeah, so that would be a way to do it. I see what you mean by chess now. But yeah, I just don't want to do that because I think it would harm the gameplay, right? Like I want it such that roads are faster and woods are slower and water is impassable. If we just had rules like in chess where, like, a knight can do this, it can make L's, that just wouldn't be as fun, right? I don't think it's what people would expect in this type of game. You're right in that would solve the problem, but I think it would harm gameplay. So I think what we're looking at is modifying the radius computation code, kind of like I was saying. You can mod the rules to fit. I could. I just think that would probably be less fun. Yeah, they're not mutually exclusive. That's true. But I just don't think I like that idea. Like I like everything from a I don't want to have to compromise my gameplay because I've bumped into a technical problem. You know what I mean? I'd rather just beat my head against this wall and solve the technical problem and leave the gameplay intact. Yeah, pretty much. That's what I'm trying to do. But I think we're on the verge here of having an idea. Let me start this music. So yeah, what we need to do though is when we're calculating these radii, for each red cell, store either every parent, or if we find that that's too expensive, store a single parent. Then we at least have a more controlled growth. Now here's what I want to know. Let's turn on our debugger, or well, our debugging output viewer. So right now we're burning 223 kilobytes of RAM. Okay, and I am already caching radii. And we can see that because every time I compute a radius, we see that number climb up. So 222, 229, 38. So it looks like we pay about 7 kilobits for every radius we compute. That was 13. Yeah, okay, so we're... Oh, fuck, dude, that's rough. So I think we have 2,000 kilobits worth of RAM to work with. And see, those radii are going to get a lot bigger if we store... If we store all that in memory, those radii are going to get a lot bigger in memory. So that's a tricky problem. Shit. Yeah, I don't know. That's the most correct way to do it. That's the way I would do it if it weren't Pico 8. But I'm reluctant to commit to that in Pico 8 because again, I don't want to. Cannot compress stuff on the fly. It cannot. This is the representation of the stuff in memory. You know, we could discard some of this stuff when it's not needed, and I mean maybe that's the solution. Is we'd have like an augmented way of calculating a radius that includes within it, you know, this extra data, and then when we're done with it, we discard it. I mean, that'd be an idea. Let's think about this though. So right now, this map has 10 units on it, and we're paying 336 kilobits, and that's 15% of our limit, not including other shit we have to do. So, like, you know, this has practical implications regarding the maximum number of units that we could have on a map before we run out of memory and crash, right? So that's why I need to think real hard on this one. I'm kind of blindsided by this tricky problem. I wasn't expecting this, actually. Now that I'm here, it's obvious, but I didn't think I had this far. Let me hit the bathroom real quick. Pico 8 problem. Yeah, it's absolutely a Pico 8 problem. If this were anything else, this wouldn't be a problem at all, right? It's just that because again, I'm talking about 2 megs of RAM, and you know that's absolutely nothing, right? But yeah, we need to make sure we stay under 2 megs of RAM. Oh, what is the bigger? Oh yeah, see, so on this stage, we start out at 336K. Did I? Oh, we're actually leaking RAM. Okay, okay, hang on. That's good and bad. Right, okay. Oh, God. So tricky. So, the reason this map loaded... Here, let's reload this cartridge and go directly to that map, and we will see... 222. Okay. Okay. So, what we just learned there is that because I have every stage and unit and stuff all in one big-ass state object... The radii of every unit on every map will never be unloaded after a map is cleared. So really I should like actually change how I'm even loading stuff, because I'm basically loading the whole game into memory. And that's not gonna cut it. Okay, so that's another... Yeah, learning has occurred. Multicart and pretend RAM. I don't think we have pretend RAM. Multicart... I don't think multicart will help us here either, because we're hitting a RAM problem, not a ROM problem. If we were worried about the size of our cartridge, multicart would be a solution. That said, I'm trying to get away from multicart too, because just for me, kind of the joy of Pick 08, right, is learning how to do this stuff efficiently. So I'd rather just solve the problems versus throw more cartridges at the problem. You know what I mean? Just like kind of as a point of pride, I want the final game, I want to be able to push it to the BBS. And if you can't export a p8.png, you can't publish to the BBS. Yeah, I don't want to cheat. I don't want to cheat. Like, there's already a game on Steam that is a Pick 08 game. There's probably a couple, but the one I'm aware of is like 16 cartridges bundled. And, you know, no disrespect to the developer, that person had a vision. But in my mind, it's like, if I'm going to need 16 cartridges, like, I should just use Godot or Unity or whatever. Like, what the hell's the point, right? I want a Pick 08 game, no asterisk next to it. I just want a Pick 08 game. Use something else. Yeah, exactly. So, yeah. So, independent of this firing position computation problem is the problem of I need to initialize stages more sensibly. Which I don't think will be a huge change. Yeah, I need some way to clear out this RAM, and you know, there are two solutions, like a good one and a bad one, right? You know, the bad one would be, as I beat a stage, just zero out all the state data from that stage, and that's a good idea, but that doesn't solve the problem, or that's not the most efficient solution. The most efficient solution is just don't load the data until you need it, and then when you're done with it, zero it out. So that problem, I forgot how I've written all that, but that problem is not intimidating. That's probably, I changed a couple of lines and it does that. So let's not worry about that one tonight. Yeah. Let's worry about the targeting problem, because that's a nasty problem. There's probably like another stupid way to do this. No, there's not. No, that's too stupid. Never mind. Too stupid. Too stupid. See, A star would solve this. I don't love that. But I mean, what I'm talking about when I'm talking about recording... And by the way, I keep saying A star. If you don't know what A star is, it's like a very common pathfinding algorithm used for games. A star is an algorithm that lets you compute the cheapest / fastest way to get from point A to point B, right? And it's just like a default, navigation algorithm used in a lot of games because it works great. It's a solved problem. But again, in Pick 08, the challenge here isn't implementing it because I already implemented it. I have the code just sitting somewhere. The challenge is that code takes up space, and we are really running low on space. If we need it, we need it, but I don't want to... I don't want to use it if we don't need it. And see, A star isn't the best solution. So A star has pros and cons. The pros are that would be useful for solving problems other than the specific problem we're trying to solve now. And it would allow our enemy to make... So we can already calculate our movement and our firing radii, but what we can't do is, given a cell that we know exists within our firing radius, we can't work backwards to the movement radius that allows us to take that shot. That's what we can't do in reverse currently. And again, in any other platform, the answer is just don't do it in reverse. It's when you build up that radius, record how you got there. But again, then we start to run into memory limitations. Yeah, that's tricky. Well, see, the issue is that we can't hack in any such table of values, or at least not as far as I'm thinking of it, because the terrain shape is unknown ahead of time, and the unit range, like attack range and movement range, are unknown ahead of time. So we really we can't pre-compute this. You know what I mean? This has to be computed either when or after the radii are computed, and ideally it would be computed at the same time, because that's just the most elegant, is to not redo the work. And that computation when the radii are computed, that is essentially like dynamically creating the table that you're talking about hacking in, right? Because we can't know it ahead of time, like for all cases, but we can pre-compute this when we calculate the movement radii because we still have access to the information, right? It's just the question is, will that information be too expensive to store when you account for all of the units? And again, our RAM and code size limitations. So we have two options, right? We could put A star back. There are two drawbacks to that. One is, I think if I put A star back, we burn like 500 tokens immediately, and we're running up. We have like space for 1,200 or something left. And also we're computing the same information in two different ways with two different algorithms. That's gross. That's gross. The advantage of A star, though, is that it would allow us to make more intelligent AI overall At least if and only if our AI solution ends up being like a conventional algorithmic solution and not something neural based. So that's arguably a plus. I'm reluctant to do it though. I just don't really like it. What does it look like when we compute our attack radius? When I Google some A-star code alternatives, the reason is because I Googled the shit out of that months ago. And I feel like I have a reasonable grasp of what I will find now. Because I was totally new to this months ago. But again, I've done quite a bit of research at this point. So I don't think I'm going to find anything that surprises me. Especially, I don't think I'll find anything that surprises me that meshes well with our game here. Given our set of, yeah. No, you're fine. By all means, feel free to ask questions and give suggestions. That's why I'm streaming, is I like talking to this stuff. Also, just like talking through this helps me to think through it. So yeah, you're helping me out by making suggestions, even if I don't, go that route. But see, like here, I mean, so again, to visualize how these radii are computed, let me turn off this annoying overhead for now. So the way these radii are computed is it's a pile of recursion. What's happening specifically is that when you click on a guy, we have each unit has movement costs. Or movement points. And each cell on the map has a traversal cost. Is math RAM intensive? Math is not intensive, but storing an assload of values is intensive. And that's what we are looking at doing if we do this the right way. Which is why I'm not sure if I want to do this the right way. But yeah, so when we compute a radius, what's happening essentially is that we have this radius, let's say class, that starts from the cell where our unit is, and then it finds the neighbors of this cell. So in the case of this guy here, here's a neighbor, here's a neighbor, neighbor, neighbor. We have 4 neighbors, right? And when it moves out to those neighbors, it deducts 1 movement point, okay? And then it does it again. So from here, it visits this cell, this cell, this cell, this cell. And then from each of them, it visits this cell, this cell, this cell, this cell. And each time it does that, it reduces a movement point. It subtracts a movement point. But it only does that... It does that recursively, right? So each time you may... Yeah, I don't think it's algebra. I don't think it is. Maybe it is. I'm bad at math, but I think this is more of a logic problem than a math problem. But yeah, so these radii are computed as like ever widening circles, essentially, whereby each time the radius gets bigger, you lose a movement point, and then when your movement points are exhausted, then you start spending attack range points. Same idea as wearing different masks. That's fair. That's true. I don't know how we would solve this algebraically though, because I think this is if anything, this is a geometry problem. It's a spatial problem, right? I think so. But so we get here. And see, the reason I say this isn't a math problem, at least not without a bunch of looping and recursion, is because of the unknown traversal costs between any 2 points. And the more I think about this, the more I think I just need to bite the bullet. I think this might be it. I think I just need to bite. I think I need to do this the correct way and just bite the bullet and figure out how to make the memory work. Because every math solution that I can think of is just going to be garbage. I think it's probably easier to just focus on solving the memory management problem. I mean, this is gross, but like, it might just be worth modifying the radius class and just giving it a method that can just do this calculation. Like the assumption is that first you pre-compute it would actually be the oh, you know what? Hey, this is neat. Hang on, this is neat. I think we can just calculate the radius from the other direction. Oh, that's cool, actually. No, think about this. Okay. Yeah, okay, hang on. I think I like this. This is actually fairly elegant. And then this wouldn't trash up our memory. So again, the reason this is difficult is because there's like all this like terrain shit you gotta worry about. And we can't make any assumptions about the terrain shit. But if we're trying to get from here to there, and we need to figure out, like if we're trying to go from point A to point B, and then we're at point B, and we need to try to figure out how to get to point A, we just fucking do the same calculation in reverse, right? We just calculate like another radius, like an arbitrary throwaway radius. I think that would do it, right? And then what we would have is we would just have like, we know that the cells that are valid firing positions are the cells that are in the subset, or it's the subset of cells in the intersection of the first and second radii, right? We calculate point A, we calculate point B, and the cells that are in both sets, the intersection of those sets, are valid. Those are valid firing solutions. And what's nice about that memory management wise is we compute that only on demand. And after we've come up with our firing solution, we trash it. So there we go. So now we're not like, now we don't have this like endlessly expanding unknown amount of RAM stored forever. That would be a disaster. That'd be a time bomb. And specifically, we only need to calculate we can even do it a little bit more efficient. We need to calculate the... I think this is correct. I shouldn't be too cute here. We only need actually, when we calculate the radius in reverse, we just need to calculate as far as the units attack range And I would say +1, but not +1 really. Rather, plus the maximum length, plus the maximum expense, the maximum traversal cost of any given tile, because we just want one. Actually, we could probably just do like range plus. No, that's stupid. We can do something like this though. I think I just need to think about this now for a little while. I'll probably do it off stream because this is tricky, but I feel confident that this is the general solution. We calculate the radius twice, and we look for intersection. That has to be the elegant way to do this. It doesn't add any code because we reuse the existing mechanisms that we already have. There's no new implementation costs, and there's no disagreement among implementations. Send code. We find our answer. We throw away the RAM. I think that's going to be I think that's going to be the solution. Yeah, but yeah, I think I need to think about this for a while and then take a crack at it next time. We might get it in its entirety next time, and then once we solve this, getting it to that first level of, you know, AI competency should be straightforward. That first layer of competency, meaning where it is at least hypothetically possible to lose to the AI, even if it's not realistically going to happen. You at least can lose. So yeah, because we need to solve this. Then we can worry about making the AI smart. And strangely, I think making the AI smart is actually going to be a lot easier than this, believe it or not, because I think making the AI smart is, I think, mostly a math problem. Well, plus with any art stuff, probably not, because I'm kind of now I'm laser focused on this, and I just want to think about this until I know I have the solution in my head. I might even take a crack at this off stream tomorrow or something. I don't know. Let's see what else we have going on though. I'll probably hop offline in a second because Peach is probably going to start in a second. I'll chill there, let my brain cool off. But okay, so we're at, let's say 7,100 of 8,200 tokens. So we have like, yeah, I want to see your hacked Pico work for sure. Yeah, we have about 1,000 tokens to go before this cartridge explodes, and we need to implement AI and at least a passable title screen, and I would say like a game over screen and a victory screen. The game over screen is like whatever, who cares? Just don't lose, don't look at it. There you go. Some kind of title screen, or sorry, some kind of victory screen, just anything. Like, I don't know, an ending or something. There's one other game feature I would like to implement, but I just don't know if it's realistic. I would like to implement a system of like hooks, just to help tutorialize the player. So like, you know, the first time your unit goes into the woods, you know, affordances John here can come up and say, oh, by the way, you know, woods have like a high traversal cost but a high defense bonus or some shit. But I might just have to like make the first couple stages really small because I just can't afford to spend tokens implementing that probably. And then I also need stage clearing dialogue. I don't have that yet, and there's probably gonna have to, that probably depends on a little bit of refactoring, which inevitably refactoring will probably add a little bit of tokens in exchange for not much. So like, yeah, I would be happy to implement the AI in like 500, 700 tokens, something like that, because yeah, god, we're gonna, this could come down to the wire just in terms of cartridge space here. One of the big advantages of the neural net thing, if I can do it, is again, we should be able to take a lot of this logic and just throw it away because like it's the neural net's job to just figure this shit out, right? At least that's what I'm thinking. And then likewise, a lot of the neural data, I need to double check this, but I think pick away the file format gives you 4 kilobits of just space in the ROM to dump whatever you want in there. That doesn't count against like your token limits or your character space or anything like that. And I would absolutely love to just take a hard problem and throw it into free space, right? I don't know if we're going to be able to get to actually do that or not, but sure would be nice. Yeah. Let's take a look at our to-do file before we wrap up for the night, I guess. See what else we got going on here. If this is too big-brained, for tomorrow or whatever, I need to think about this more. I might just take a night and start working on like sound effects and crap that's like pretty chill. Because I'd rather think a while on the hard problems, at least if I feel like I need to. Maybe I will, maybe I won't. Oh, then there's just some stupid bugs to solve. This also pertains to the radius here, but right now, yeah, it's possible for enemy units to move off screen, which isn't great. They can stack. I know why both of those things are happening. I don't entirely know how I want to solve the problem, but I'm aware of what's happening. The camera's kind of shit. Yeah, so next time I stream, maybe tomorrow, I'll either tackle this big brain problem, or fix some bugs, or just work on sound effects or something. I think that'll be the plan. But yeah, anyway, I'm gonna wrap up for the night. Thanks for hanging out, and yeah, Usagi, I'll see you in Discord. So whoever else is here, we'll catch you next time too. Have a great night. I'll see you next time.